This lesson will familiarize you with the 737 pressurization system. Upon completion of this lesson, you should be familiar with basic pressurization concepts. You should be able to identify pressurization system components and control, and you should be able to recognize both normal and abnormal pressurization system operation. Air used for pressurizing the airplane comes from the air conditioning packs. Pressurized areas are the cockpit, the passenger cabin, the E&E compartment, and the cargo holds. Air pressure is regulated by opening and closing the main outflow valve. To lower air pressure inside the cabin, the main outflow valve is opened, increasing the amount of cabin outflow air. To raise air pressure inside the cabin, the main outflow valve is closed, decreasing the amount of cabin outflow air. To understand the concept of airplane pressurization, three types of air pressure must be differentiated. Ambient pressure is the outside air pressure. Cabin pressure is the pressurized air inside the air, and differential pressure is the difference between the cabin pressure and the ambient pressure. Air pressure is measured in pounds per square inch, PSI. For example, at 34,000 feet, the ambient pressure is approximately 3.6 psi. If the cabin is pressurized to an altitude of 5,000 feet, the cabin pressure is approximately 12.2 psi. The differential pressure is the cabin pressure minus the ambient pressure, or 8.6 psi. The higher the differential pressure, the more stress there will be on the airplane hull. For this reason, pressure relief valves limit the differential pressure to a maximum of 8.65 psi. Flights below 18,500 feet can maintain the cabin altitude at sea level. Maintaining a safe differential pressure above 18,500 feet requires raising the cabin altitude. As the cabin altitude is raised, the cabin pressure decreases.